go against the clock, counterclockwise. So if we travel from X to A, the only information we need to know is how many degrees we're turning from point to point. And y'all were asking about the rotational symmetry. That's also the degrees when it's asking about angles of rotation. That's what we're doing in this problem as well. So how many points are there? 8, just like in the warm-up, right? So we know that we're traveling 45 degrees each time. So that's why 3A is 45, okay? Now everyone was asking about these at the bottom, or 4 through 6. First of all, types of symmetry. So let's start with, you check every shape and you see if it has reflectional symmetry. The way you do that is you draw some lines and you see, does it look the same on this side of the line as it does on this side? And you draw another one. This is a square. It's a regular quadrilateral. We learned that if it's regular, it has the same number of lines of symmetry as it does the number of sides. So we know this has 4. We don't even need to draw it. It has 4 because it has 4 sides. So I'm going to put line, even though we know it's also called reflectional. And there's 4. 1, 2, 3, 4. Okay. Angles of rotation. So does it have rotational symmetry? I want you to picture the shape, and I want you to turn it. When you turn it, does the shape land on top of itself? Is it congruent to how you started, except for the letters? You know what I mean? The orientation. Orientation is actually the same. But so if I rotate this 90 degrees, my shape is going to look the same as how it started. That means it has rotational symmetry. So it's got line, it's got rotational. How many degrees can I rotate it, and the shape looks the same as how it started? I can rotate it 90, it'll still look like that same square. I can rotate it 180, it'll still look like the original figure, and I can, of course, rotate it 270. How come I don't list 360, which would be the next one? Well, 360 doesn't count because all shapes you can rotate it 360 degrees and end up how it started, okay? So, let's do number 5. Number 5 is also a regular polygon. That's a pentagon. How do I know it's regular? All sides have tick marks, all angles have arcs. So I already know definitely has line symmetry, and I know how many it has. It's a pentagon, so it has 5. I'm not even going to draw them. Okay, now rotational symmetry. Since it's regular, if I take that thing and I rotate it, it's going to land where it started. I don't know if I'm describing that very well. And how do I know how many degrees it rotates each time? I take 360 and I divide it by the number of vertices, 5. And so that's how I know where it lands each time, how many degrees you rotate each time, rather. So 360 divided by 5 is 72. That's when I go from here to here. What about when I rotate from here to here? Well, I just take 72 and I double it. And then I take 72 and I triple it. You get the idea? And you keep doing that. Keep doing that until you get to 360 and you know you're done. Okay? Last one. Number 6. This figure doesn't have any symmetry. The reason is I could try to draw all sorts of lines. Just play with it. Is it equal on the left as it is on the right? Is it a mirrored image? No. Do this one. Is it a mirror image? No. Try this one. Mirror image? No. Also, picture rotating it. If T went to W's spot, would the figure look the same? It would look different. If T went to V's spot, would it look the same? No. You cannot turn this except for 360, and it wouldn't map to itself. Okay? All right. Next one. Number 8. How many degrees would you rotate to get from vertex to vertex in a nonagon? Who had to Google nonagon? Who had to ask the internet what a nonagon was? 9-sided figure. So we are assuming it's regular, because if it's not regular, you throw this question out the window. So all you do on number 8 is 360 divided by 9, because there's 9 vertices in a nonagon. Okay? Number 12. I like this unit. It's fun. Okay, number 12. This one could show up on the quiz today. I told you to memorize your 4 rules. I just want you to memorize them. You reflect over the x, you change the y. You reflect over the y, you change the x. In this problem, if you reflect over y equals x, you do the switcheroo thing. You do Freaky Friday. They just trade places. It helps sometimes for some students to write the rule above the answer. Let's write the rule. This is on your notes page. There's the rule. YX. So now I'm just going to follow the rules. This first one says take Y and do nothing to it. Take Y and do nothing to it. The next one says comma, take X and do nothing to it. Take X and do nothing to it. So that's why the answer is 5, -3. They just trade places. All right. Last problem, 16. Point H, rotated, we're going clockwise this time, 144 degrees. Now, how many do we rotate with each from letter to letter in this shape here? This one's different. How many do we rotate from letter to letter? Right, so there's 10 letters, right? So 360 divided by 10. So we're going 36 degrees from letter to letter. So now you say, oh, I need to go 144. So how many 36 degrees do I need to go? You could just divide it. 144 divided by 36. I need to go 4 letters. I need to go 4 of them. And I want to go the way the clock goes. 1, 2, 3, 4. The answer was B.